Hi everyone, I'm Matthieu, a PhD student at Imperial College. I'm very excited to talk about our work on document level membership inference against LLMs. So I think we all know that LLMs are increasingly everywhere. They're increasingly embedded into our daily lives. Their capabilities come from an increasing amount of parameters trained on a huge amount of data. And at the same time, we see that questions are being raised about what these LLMs actually learn from. They could propagate bias, misinformation, they might be trained on copyright protected content, they might have data contamination with evaluation benchmarks, and at the same time, we see that LLM developers actually become increasingly reluctant to disclose details on the training data set. That's why we work and introduce document level membership inference for LLMs. So imagine you're a content creator and you own a particular piece of text. It can be a document, can be a book, can be an academic paper. And a certain LLM is out there, is trained on a huge amount of data and eventually released with black box access. Then the goal would be for this content creator to infer whether this document has been seen by the LLM during training. So this is a task we propose and try to solve. Importantly, I want to devote half of the presentation about how we actually approached it in our original paper. But the other half of the presentation, I actually want to talk about how the field has moved on since we submitted our paper, and concerns have been raised about document level membership inference in practice. So I want to also discuss that. But first, how we actually approach this. And in our approach, we consider two big steps. And one of them starts with the collection of member and non-member documents. And what does this mean? We know that LLMs are trained on a huge amount of data, typically scraped from the internet, and it also includes documents like books from Project Gutenberg, from Books 3, but also from academic papers from archive. So the goal here now is, can we, for a certain target LLM, collect documents that either have been used or have not been used to train the model? For members, documents that have been used to train a model, we can actually sample documents from data sets that are widely used to train LLMs. Like Hugging Face has a huge amount of data sets, for instance, PG19, or Wikipedia articles that are typically used to train LLMs. So we can reasonably assume that documents sampled from these data sets have been used to train the LLM. For non-members, we actually realized that some of these platforms that host data, like Project Gutenberg or Archive, actually continuously update their data, which means that we can collect documents that have been uploaded on these sources after the model release date, and thus reasonably assume that the target model that we consider has not been trained on this kind of data. So for academic papers, we just sample papers from that were released after the model release date. For books, we do the same for books that have been made available on Project Gutenberg after the model release date. Interestingly here, and we'll come back to that in a bit, we wanted to make sure that in Project Gutenberg, there's like a wide range of books being actually published, going from Shakespeare to books made available in the public domain recently. And we wanted to make sure that we only consider books that are similar in language. So we control for the publication year of books, only between 1850 and 1910. But more on that in a bit. So the next step, when we have this data set of member and non-members for a certain LLM, we actually want to build a document level membership classifier. And from a high level, what we want to do is take the tokenizer of your target LLM and tokenize all the documents that we have, member or non-member. This can be, depending on the document type, it can be for a book, for instance, more than 100,000 tokens. Then we want to query our target LLM for token level probabilities, which again will result in a list of more than 100,000 probabilities. Then to increase membership information, and more on that in a bit, we want to normalize the token level probabilities to increase membership information. And then we want to extract features on the document level that we can actually feed into a membership classifier that has basically a binary prediction task to predict 1 or 0, where 1 corresponds to this document has been seen by this LLM during training, while 0 corresponds otherwise. For more details about these exact steps, I refer to the paper. I just want to give you a couple more intuition about what we actually do and why we do it. But step 1 is querying the LLM. How we actually do this is, so we tokenize the entire document, and then we will take the LLM and run through the entire text and to actually query the model for what is the probability that you predict the true token rumors given a certain context in gray. And then we'll run through the entire text of the document to get probabilities for each token in the document. And then we actually hypothesize that, okay, a large probability can either mean that the model is very good at generalizing to new language, rather than indicating that it has seen this document during training. And this is why we actually want to normalize our token level probabilities. And we consider multiple approaches in the paper, but for simplicity, the main one is that we just we take the ratio of the probability of the predicted by the LM divided by how frequent a token appears in a reference dataset. So that brings us for one document to a distribution of normalized probabilities of all the tokens. And we want to create document level features from this. So what we do, we consider a certain range and we divide that range into bins, 1,000 bins in particular. And then we query what's the fraction of tokens in a certain document that correspond to a certain bin of normalized probabilities, which we then feed into a simple random forest classifier to predict binary membership on the document level. And then we apply this methodology to OpenLlama, which is an open reproduction of Llama, to be in full control of the data that's been used for training. And what we do find is that this actually reaches an AUC of membership that is very high, of 0.86 for books and 0.68 for archive papers. So these are the results and the methodology that we discuss in the paper. But what we've realized in recent months is that the field has moved on. On the one hand, there's been more and more work on exactly this, on post hoc MIAs against LLMs. In work very concurrent to ours that was published at iClear 2024, has proposed pre-training data detection of LLMs. And similar to us, they also rely on post hoc collection of non-member documents. They use Wikipedia articles instead of books. And they also reach a membership AUC of 0.8 plus across a variety of models. And the same data set that they then release is used in subsequent works that evaluate LLMs, MIAs against LLMs. But also, recently, concerns have been raised about this, and specifically about this post hoc collection of non-members. That this actually constitutes a distribution shift between members and non-members, which means that if you have a certain AUC, that we might not be able to attribute that to the LLM memorization, but rather to a membership classifier focusing on this distribution shift. So let's dive in a bit to that. And this recent work that have, like in the last 2 months, proposed like model-less baselines to measure this. Like, can I, without even looking at the target LLM, just looking at the data, distinguish members from non-members? And people have proposed bag-of-words methods to do it. And what happens if you actually apply this to the set of member and non-member documents that we have for both Project Gutenberg and Archive as the data set of our concurrent work? And we actually see that this bag-of-words classifier reaches an AUC that is even higher than the one that we reported for our membership classification. And this basically means that the AUC that we reported previously is not attributable to the LLM memorization. And what I want to note is that this distribution shift can be very subtle. Like, remember that we tried to control for the original publication year of the books. Well, it turns out this was not sufficient. And when we look at most predictive words in a bag of words classifier, we actually see that this includes, for instance, the use of politically incorrect language, where this means that books, while originally published in the same year, the fact that they're uploaded on Project Gutenberg at a later stage actually means that they contain less politically incorrect language, which is quite subtle. So what are the alternatives to develop MIAs on LLMs? I think there's a range of models out there that provide a randomized split of train and test data that they have used for evaluation. And I think this provides a great setup to develop and evaluate MIAs, but it also comes with its challenges. I think first, researchers actually found there's a significant overlap between members and non-members there, which basically means that it becomes harder for MIAs to succeed. And secondly, such a randomized split is typically not available for most LLMs. An alternative approach is you could sample members and non-members as closely as possible to a certain cutoff date. And this is actually what we've done in a follow-up work that I'll link in a bit. And we instantiate this in our setup for archived papers specifically, where we consider members and non-members just 1 month apart. If we then apply the same bag of words classifier as model as baseline, we find an AUC of 0.52, which basically means, assuming the classifier is good, that the distribution shift is largely mitigated. And if we then apply the method that I talked about before and introduced in the paper to the setup, we find an AUC of 0.54, which either means that our attack is not sufficient or that these language models don't memorize as much about their content as we previously thought. Other approaches, and I think this is probably the most favorable one, is some kind of controlled injection of highly unique sequences in the pre-training dataset, which has been proposed, like for instance, copyright traps or data watermarks at ICML. So in conclusion, there's more and more questions about the transparency of pre-training data, while LLM developers are increasingly reluctant to disclose any details on the training data. We propose a task of document-level membership inference and a method to do so, but we also identify that implementing this in practice becomes challenging. And it still needs to be determined, first of all, if such an attack works in a clean setup, and second, if a clean setup can be created for real-world LLMs. In any case, we emphasize the need of a clean and controlled setup to develop and evaluate MIAs against LLMs. So yeah, thank my collaborators, of course, and I linked the main paper, the follow-up paper, and the code that we also release as part of this work. Thank you so much.